Beneath the Geneva gloom, far below the world's surface, lies a stunning triumph of human ingenuity, and an inevitable harbinger of devastation, the Large Hadron Collider, LHC. It stands as a marvel of intelligent analysis, allowing researchers to investigate the subatomic realm and triggering the discovery of the elusive Higgs boson, often dubbed the God particle. This breakthrough has captivated the scientific community. As Brian Cox, a well-known physicist, once ominously declared, a hidden potential has been uncovered at CERN, sparking both curiosity and concern. Could our quest for knowledge have taken us down a dangerous path? Have we set our course for an uncertain future, possibly one beyond our comprehension? Before delving deeper into this startling statement, it's essential to first take a look at the gigantic machine that is the Large Hadron Collider. Operated by CERN, the LHC is a massive 17-mile, 27-kilometer, ring of superconductive magnets and is, without a doubt, the strongest and largest particle accelerator ever built. It stands as the pinnacle of scientific accomplishment, capable of recreating conditions that rival the universe's creation itself. This incredible apparatus allows researchers to investigate the fundamental components of the cosmos. But with such immense power, could it lead us to unforeseen consequences, possibly even into the realm of the unknown and terrifying? With its roots in 1954, CERN has become one of the world's most prestigious and vital research centers, boasting 23 member states and a vast network of experts. While the LHC is its most high-profile project, it is only one part of an expansive array of accelerators and detectors aimed at understanding the universe's smallest components. The LHC is a race to uncover the very building blocks of existence. It accelerates protons to nearly the speed of light, sending them on a collision course that simulates the energy and conditions of the universe's inception. The temperatures produced are millions of times hotter than the sun's core, while a complex network of magnets guides these particles along their journey. At the same time, highly sophisticated cooling systems maintain the system's extremely icy surroundings, far colder than even outer space. Equipped with 1,232 dipole magnets to steer the protons and 392 quadrupole magnets to focus the beams, the LHC increases the probability of collisions by pushing particles together with incredible force. The objective is to collide particles with such precision that it is akin to hitting two needles placed 6 meters apart, an operation requiring mind-boggling accuracy and unmatched technological sophistication. The collider's construction features concentric rings placed deep underground, shielding them from harmful radiation. To attain optimal performance, the entire system is cooled to -456 degrees Fahrenheit, even colder than the vacuum of space. The underground setup houses 4 distinct particle detectors: ALICE, LHCb, ATLAS, and CMS. Each serves a unique purpose in investigating various aspects of particle physics. These detectors are equipped with massive cameras that capture particle impacts, with experts constantly analyzing the data in search of traces of the elusive Higgs boson. The Higgs boson is considered essential to understanding the very fabric of the universe. It provides insight into the fundamental structure of matter. In many ways, studying the microcosm helps us unravel the macrocosm, much like solving a massive, cryptic jigsaw puzzle. However, with each piece we place, new questions and mysteries emerge, reminding us that every discovery leads to another challenge. The LHC is not merely a scientific tool, it is an embodiment of human ambition, progress, and the relentless drive to comprehend the fundamental forces that shape our universe. But as we venture into the unknown, we must also confront the moral and existential dilemmas that accompany such daring exploration. What are the potential risks of delving into the unseen? Could our quest for understanding unleash forces beyond our control? In recent months, an unsettling revelation has shaken the scientific community. Brian Cox, a former CERN researcher and a prominent voice in particle physics, made a statement that both intrigued and alarmed his colleagues. According to Cox, the goal of the LHC, to recreate a miniature version of the Big Bang, could lead to unforeseen consequences. The collider's ability to investigate the depths of the Higgs boson and probe the dark enigma, the mysterious substance that makes up a significant portion of the universe, could potentially unlock truths beyond our comprehension. While the idea of locating and studying the darkest parts of the universe is exhilarating, it is also fraught with risk. The LHC recreates the extreme conditions present at the universe's inception, simulating temperatures, pressures, and energies unlike anything we observe in everyday life. It is as if we are peering directly into the moment the universe began, yet such immense power brings with it immense responsibility. Consider the incident involving Russian physicist Anatoly Bugorsky. In 1978, While conducting research at the U-70 synchrotron at the Institute for High Energy Physics, a tragic accident occurred. A proton beam accidentally penetrated his skull, causing significant tissue damage. Miraculously, he remained conscious and even walked to seek medical attention. His experience is a stark reminder of the potential dangers associated with particle accelerators. The power harnessed by these machines should never be underestimated. Concerns about the LHC's capacity to create black holes, albeit on a very small scale, have raised alarms among some in the academic community. Black holes are regions of space with gravity so intense that not even light can escape. Some scientists have expressed concern that the LHC might generate a tiny black hole, which could theoretically destroy the planet from within. While CERN researchers have reassured the public that any black holes generated would evaporate almost instantly and pose no threat to Earth, this theoretical possibility has nonetheless sparked fear and intrigue. The idea of a black hole created by high-energy particle collisions has been the subject of ongoing debate, contributing to growing awareness of the risks associated with such powerful experiments. Understanding the mechanics of the LHC is crucial for grasping its potential to create black holes. When protons are accelerated to near light speed, the energy produced is so immense that it distorts the fabric of spacetime itself. This effect can be likened to jumping on a trampoline, causing the surface to bend and warp. These distortions raise an unsettling question: could such shifts lead to the formation of a black hole? In the strange and mind-bending realm of quantum physics, where the universe's fundamental laws appear to defy logic, some theories suggest that unknown aspects of our reality may be hidden within the very fabric of space. If such components exist, the LHC could potentially tap into them, sparking the creation of a gravitational anomaly capable of forming a black hole. This possibility has garnered attention from some of the world's most distinguished scientists, including the late Stephen Hawking. In his writings, Hawking warned of potential dangers if the Higgs boson behaves unpredictably at high energy levels. Such an anomaly could trigger a catastrophic event known as vacuum decay, a phenomenon that could not only the particle which is believed to endow other particles with mass may also hold clues about the stability of our universe, the nature of dark energy, and even the future fate of the cosmos itself. Its discovery was not merely a confirmation of the standard model of particle physics, it was a gateway to a deeper, more profound understanding of reality. Despite the awe-inspiring scope of its mission, the Large Hadron Collider has become a flashpoint for public debate, stirring both excitement and apprehension. Critics argue that our rapid technological advancements have outpaced our ability to predict or control their consequences. Others contend that fear should not hinder the pursuit of knowledge, especially when that pursuit has the potential to unlock the very secrets of creation. Indeed, throughout history, the most groundbreaking scientific developments, from electricity to nuclear power, were often accompanied by resistance and fear. What separates the LHC from past endeavors is the sheer scale and abstractness of its mission. We are no longer splitting atoms or observing chemical reactions, we are manipulating the very threads of existence, unraveling the blueprint of the universe, and venturing into domains previously relegated to philosophical speculation or science fiction. The possibility that the LHC could open a window into alternate dimensions, expose us to unknown quantum fields, or destabilize our understanding of spacetime is both exhilarating and terrifying. This is not simply the stuff of speculative fiction, it is grounded in real theoretical physics. While most experts agree that the chances of catastrophic scenarios are minuscule, their mere plausibility demands that they be taken seriously. As we continue this unprecedented journey into the quantum frontier, the LHC serves as a beacon of human potential and a mirror reflecting our deepest anxieties about our place in the universe. It reminds us that progress is not without peril, and that the more we come to know, the more we must reckon with the vast unknown that still lies ahead. What does it mean to possess the tools to recreate creation itself? Can we be trusted with the keys to the cosmos? These are not merely scientific questions, they are ethical, philosophical, and existential ones. They force us to examine not just what we know, but why we seek to know, and at what cost. In the end, the LHC stands as a monument to our species' insatiable curiosity and ambition. It is a triumph of global cooperation, a marvel of engineering, and a symbol of both our brilliance and our hubris. As we peer ever deeper into the fabric of reality, we must also peer inward, toward the conscience that guides our discovery, and the wisdom we must summon to wield our knowledge responsibly. Integral to the standard model of particle physics, the Higgs boson plays a crucial role in giving other particles mass. Without the Higgs field, the universe would be vastly different, with particles floating around in an empty, massless state. However, beyond the fundamental comprehension of the Higgs, scientists are also keen to understand how the particle behaves under extreme circumstances. These studies could lead to insights that impact everything from the creation of brand new materials to understanding the fundamental forces that govern the universe. One of the other critical aspects of the LHC is its exploration of the invisible substance known as dark matter, a substance that accounts for around 27% of the total mass and energy of the universe. Despite its immense presence, scientists have not yet detected dark matter directly. The LHC's experiments aim to reveal the potential particles that may make up dark matter by observing the behavior of particles created during high-energy collisions. If dark matter is finally identified, it could change how we see the universe, unfolding spacetime's hidden dimensions and altering the foundations of modern physics. In addition to dark matter, the LHC is exploring other exotic realms such as supersymmetry and the potential existence of additional superdimensions. Supersymmetry is a theory that proposes a connection between two fundamental classes of particles, bosons and fermions. This theory predicts the existence of superpartners, particles that have yet to be observed. Supersymmetry could open the door to a new understanding of nature's fundamental forces, providing a deeper understanding of the interactions that govern our world. Additionally, the LHC is essential in advancing quantum computing. By understanding the behavior of subatomic particles, researchers can gain valuable insights that could revolutionize the way we process information. Quantum computers, operating in accordance with the theory of quantum mechanics, have the potential to solve problems that are currently beyond the reach of classical computers. The technologies created specifically for the LHC's experiments, such as specialized sensors and cutting-edge computing algorithms, have already influenced the field of quantum computing, paving the way for future breakthroughs. Despite its unquestionable advantages, the LHC's work also raises fundamental questions about the future of humanity. The search for the unknown can be thrilling, but it also comes with the responsibility of considering the possible unintended consequences. The very technology that drives the LHC could be used for purposes that are harmful to humanity, such as in the progression of advanced weapons or creating scenarios beyond our control. Ethical debates surrounding the LHC are not limited to just the risks of catastrophic events like vacuum decay or black holes, but also include the potential application of the research. How do we ensure that this knowledge is used responsibly and that the pursuit of discovery does not inadvertently lead to harm? As we explore the unknown, it is crucial to engage in ongoing conversations about the balance between scientific progress and ethical responsibility. The global nature of the LHC's work necessitates the cooperation of multiple countries, each with their own values, priorities, and concerns. Transparency in research, accountability, and collaboration between nations will be essential in ensuring that the knowledge gained through these experiments benefits humanity as a whole, rather than causing unforeseen damage. The work of CERN through the LHC serves as a reminder that scientific achievement must always be tempered with careful examination of its broader consequences. Another issue of concern is the potential for unforeseen ecological impacts of particle accelerators. While the LHC is a relatively contained environment with no immediate environmental consequences, the enormous amount of energy required for such machines cannot be ignored. The environmental footprint of particle accelerators, especially those requiring enormous quantities of electricity and producing heat, could strain natural resources and ecosystems. The LHC has enormous energy requirements. Although efforts are being made to use renewable energy sources and improve efficiency, the broader question of sustainable scientific exploration must be addressed. Ultimately, the path forward will require a delicate balance. The LHC represents humanity's drive for knowledge, exploration, and discovery. However, as with all scientific breakthroughs, there comes the need for ethical reflection and responsibility. The risks involved in such experiments cannot be overlooked, but the potential benefits could reshape our understanding of the universe in ways we can only begin to imagine. As we continue this journey into the unknowable, our focus must be ensuring that scientific research progresses in a way that is safe, responsible, and beneficial for future generations. In conclusion, the Large Hadron Collider is much more than just a tool for scientific discovery. It is a symbol of humanity's quest for knowledge and its boundless curiosity concerning the nature of existence. The questions raised by the LHC's work are profound and carry significant ethical and existential considerations. However, the LHC also demonstrates that, through collaboration and careful oversight, we can unlock secrets that have the potential to change the course of history. As we stand on the precipice of these new discoveries, we must remain vigilant, mindful of the potential risks, and committed to the ethical use of the knowledge we uncover. In the end, the quest for understanding must always be guided by the responsibility to protect our future. As research at the LHC advances, it also prompts deeper philosophical inquiries. What is the ultimate nature of reality? Are we merely scratching the surface of a multiverse far more complex and layered than our current models suggest? These questions, once the realm of speculative philosophy, are increasingly relevant in the light of experimental high-energy physics. The possibility of parallel dimensions, the reconciliation of general relativity with quantum mechanics, and the unification of fundamental forces all point toward a future in which science and metaphysics may begin to converge. Moreover, the technological ripple effects of the LHC extend beyond the boundaries of physics. From medical imaging advancements inspired by particle detection technologies to innovations in data processing, storage, and AI algorithms, the practical applications of LHC-related research are already influencing multiple industries. It is a powerful example of how pure science, often seen as abstract or removed from daily life, can seed revolutions in healthcare, communications, and infrastructure. Yet with great potential comes a greater need for scientific literacy among the public. As discoveries accelerate, bridging the gap between scientific communities and the general population becomes imperative. Without a widespread understanding of what the LHC is, what it does, and what its discoveries mean, public trust may erode, especially in the face of fearmongering or misinformation. Thus, science communication, clear, honest, and engaging, must evolve in parallel with scientific achievement. CERN has already taken steps in this direction, offering public tours, educational programs, and open-access publications. But more can be done. Engaging with students, creating partnerships with schools and universities worldwide, and involving interdisciplinary voices, philosophers, ethicists, artists, can foster a cultural environment where scientific exploration is not only respected but enthusiastically supported and understood. Finally, the LHC stands as a monument to what humanity can achieve when we cooperate across borders, ideologies, and languages. In a world often divided by conflict and competition, the Collider reminds us that knowledge is a shared heritage, and the universe belongs to no one group or nation. The spirit of discovery that fuels the LHC is universal, transcending politics and profit. As we look toward future upgrades of the LHC and the development of even more powerful accelerators, such as the proposed Future Circular Collider, FCC, we must carry forward the lessons of this era, pursue knowledge bravely, but carry the torch of responsibility with equal care. The universe may not give up its secrets easily, but with patience, cooperation, and conscience, we may one day understand not only how it works, but why it exists at all.